Hello, am I audible? Can anyone confirm? Hello. Okay, thank you. So, good afternoon, everyone. Welcome to this live session for the NPTEL course Introduction to Machine Learning. So, this is a live session for this course, and in this session, I will mostly discuss some sample practice problems for week 1 and week 2. And I will also try to answer your questions and queries, and I will also try to clear your doubts if you have any regarding the week 1 and week 2 material. These 2 weeks have been taught so far. So let's begin. Is my screen visible? Okay, thank you. So these are the logistics of this live sessions. Like the start date is 4th February, which is today. So today is the first session, and I will conduct live sessions on every Saturday from 3 p.m. to 5 p.m. and this is the meeting link to join this live session. And another important thing to note is that this is a 2-hour long live session, so from 3 to 5. But the Google Meet doesn't allow meetings for more than 1 hour. So after the first hour, that is from 3 to 4, after 1 hour I will share a new meeting link for the second hour, and you have to join using that meeting link for the second hour, which is from 4 p.m. to 5 p.m. Because we cannot have meetings for more than 2 hours using normal Google account meetings. So for that I will create a new meeting link and share in this meetings chat, and I will also announce it after 1 hour that I have created the meeting link and I have shared it in the chat, and you will have to follow that meeting link to go to the next go to the new meeting for the next hour of this live session. And make sure that you click that meeting link first and then leave this meeting, otherwise you will lose the meeting chat, because once the meeting is ended, then the chat content is lost. So first you have to click the meeting link and then you have to end this meeting. So I will inform all of you after 1 hour when you will have to do that. So is my screen visible now? The screen shut down suddenly, so I have to reshare the screen. Is it visible now? Okay, so we will first discuss some sample practice problems for week 1 and week 2. So this is the first problem. Let's wait for 2-3 minutes. More people are joining, so it's difficult for me to start this session. So let's wait for 2-3 more minutes and then we will start discussing the problems. Yes. I will mostly take the doubts after this problem solving part, so that otherwise it would be difficult to manage because there are so many students. But yeah, you can ask now. Okay. Okay. Yes. 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 Mm, I mean, I don't think especially for geophysics or geologists any content is present specifically for them, because this is a general course for everyone, for every branch. So not specifically for them, but the algorithms are applicable in all fields, whether it's computer science or electrical engineering or geophysics. The algorithms are to be taught in the class. I mean, what the instructor would teach in the video lectures would be applicable to any field. So it is useful for all the fields, so that is not a problem. But specifically for them, I'm not sure if for geophysics any applications are given there or not. I mean, I don't have much knowledge about geophysics. I mean, I don't have any knowledge about geophysics or any related field. So I will not be able to uh, help in that regard. Uh, but the video lectures are pre-recorded, so it's not possible to include extra video lectures. So what the four TAs would be doing is that they would be conducting live sessions like this, and they would be mostly try to clear your doubts and solve some practice problems. Uh, yeah, the video lectures are pre-recorded videos. I mean, in the NPTEL website, all the videos that you are watching, the week 1 and week 2 have already been released. So all those are pre-recorded, and such 12 weeks recording is already there. Yeah, and along with these live sessions, so these live sessions are for interactions with the students, and the TAs would be conducting these live sessions. There are four sessions every week, so you can attend only one of them, or if you want, you can attend all four of them. Uh, it is up to you, but there are four parallel sessions going on, so that you can attend at least one. Yeah, I mean, if you want, you can attend other sessions also, and you can also check out how other TAs are teaching. So you can do that, but it is up to you whether you want to attend one session or all four sessions. No, there are four other total four TAs are there. So each of them would conduct one session every week. A teaching assistant. Yeah. Yeah. Thank you. So now, yes. The NPTL assignments for this course. If the deadline is over, you cannot submit after that. If the deadline is somehow extended, I don't know whether they extend it or not. I don't think they extend. This is handled by NPTEL themselves. Uh, and also these live sessions, I mean, we don't handle even the assignments, we don't create or we don't handle at all. The assignments are created by the instructor and the regular TA for this course. We are the additional PMRFTs for conducting these live sessions, so we don't manage the assignments or assignment solutions at all. There is some condition, I think, that you have to no, I'm not very sure about what is the condition for the certificate. There is some marks percentage condition is there, so you have to check in the course web page that for certificate how many assignments you have to submit, or if you have to submit all 12 assignments. So you have to check in the course web page. But assignments are not managed by us, these live session TAs, so we don't have much idea about that. Yes. Not exactly. I mean, it might contain some similar questions, some different questions as well. You can check out other sessions also. It might not be exactly same. Uh, so if you want, you can attend only one of them, or you can attend all four of them. It's up to the student. So I mean, all these each session is of 2 hours, so it's very difficult to attend all 4 sessions. That is total 8 hours we have to just attend those doubt clearing sessions. Like today only there are this, after this session there is a 5 to 7 session, then again there is a 7 to 9 session as well for this same course. So it would be difficult for him, one student, to attend from 3 till 9 p.m. So it's not possible. I mean, if you want, you can, but there is no need to attend all 4. You can attend any number of sessions you want. So many of you joined a little late, so let me introduce myself. So I am Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur, and I will conduct live sessions every Saturday for 12 weeks from 3 p.m. to 5 p.m. Using this meeting link that you can see on my screen. And another important thing to note is that this is a 2-hour long live session, but Google Meet doesn't allow meetings for more than 1 hour using normal Google accounts. So for the second hour, that is for 4 p.m. to 5 p.m., I have to create a new meeting link, and I will share with all of you in the meetings chat, in this meetings chat, and you have to click on that meeting link and join that meeting for the second hour, that is 4 p.m. to 5 p.m. So I will after 1 hour I will let all of you know that I am creating a new meeting link, and you have to join that meeting. And also you have to make sure that you click that link first and then leave this meeting for this second hour, otherwise you will lose this chat once this meeting is ended. Everyone please yes, yes, yes. I mean, in NPTEL, that, I mean, I don't know. I don't know how many exams one can write. You can contact the NPTEL team itself, so they would be able to. Yeah. Yeah, I think we should start this live session. Yeah, we should start solving problems now. It's already 15 minutes past 3. So I will discuss some sample problems from week 1 and week 2, because these 2 weeks have been already taught. So this is the first question. Which of the following are supervised learning problems? There are 4 options. Learning to drive using reward signal, predicting disease using from blood samples, grouping students in the same class based on similar features, face recognition to unlock your phone. So which of the following are supervised learning problems? Everyone please mute yourselves, otherwise some noises are coming. You can write your answers in the chat. So these are the 4 options, and which of the following are supervised learning problems? I hope most of you have gone through the material for week 1 and week 2, so you'll be able to answer answer this, which of the following are supervised learning problems. So multiple may be correct, so you have to consider that as well, and there may be multiple correct answers in this. Yeah, so many of them have already written in the chat B and D. So the correct answers are actually B and D. So supervised learning problems are those problems where the data contains the training data contains class levels, sorry, not class levels, output levels, or the target variable is there in the training data, and the model is trained using the labeled training data. So there is a target variable or output variable is there. So out of these 4, we can see that the predicting disease from blood samples. So this needs label data. The label is the disease, which disease you are predicting. So this is a supervised learning problem. Similarly, option D, which is face recognition to unlock your phone. So this also has this label, which is whether it's your face or not. So yes or no, this is also the label that should be present in the training data. So these 2 are supervised learning problems, and A and C are not supervised learning problems. As you can see that A is learning to drive using reward signal. So if you have already gone through the introductory the first 3-4 videos, this is actually what is reinforcement learning, which is reinforcing the agent using reward signals to learn to do some task. So the option A is not reinforcement learning, not supervised learning, it is reinforcement learning, option A. And C, grouping students in the same class based on similar features. So this is also not a supervised learning problem, because grouping or clustering objects is unsupervised learning problems. So you don't need the labels, you will group or cluster the objects based on their similarities. So that is unsupervised learning problem. So B and D are the 2 correct answers. Many of you have already written it in the chat. So this is the second problem. Which of the following are classification problems? Again, multiple answers may be correct. A, predict the runs predict the runs as cricketer will score in a particular match, predict which team will win a tournament, predict whether it will rain today, predict your mood tomorrow. So these are the 4 options. Which of the following are classification problems? Write your answers in the chat. So classification problems means the problem classification problem is certainly a supervised learning problem, and you will classify a certain data point into one of the classes. So there should be a set of finite number of classes, and you will classify a given data point to one of those classes. That is a classification problem. So from that point of view, if you see that the option A, which is predict the runs a cricketer will score in a particular match, so this is not a classification problem, because a cricketer can score any amount of runs from starting from 0 to infinity. So there is no such finite set of the classes present. Predict which team will win a tournament. So there are certainly a fixed number of teams present, and one of them will win the tournament. So B is certainly a classification problem. You will classify which team would win this tournament. So that is a supervised learning problem. Similarly, predict whether it will rain today. So whether it will rain today, not the amount of rain, but whether it will rain today. So yes or no question, which is again a classification problem. Predict your mood tomorrow. So predicting mood means there are a finite number of moods, and you will predict or classify one of them. So that is also a classification problem. So correct answers are B, C and D. So many of you have already given B, C and D. Some of you have written A, B, C, D, which are not right. B, C, D are right. So is there any doubt in this previous question, question 2, classify? Yes. Yes. Why? No, the videos will be uploaded in the YouTube after this session. I am already recording the session, and the recorded sessions, I mean the links will be shared by NPTEL with all of you later on, I think. So we will upload these videos in YouTube, so you will be able to watch the videos later. I cannot hear you. Hello? I mean the links might be shared by NPTEL later on. So after the videos are uploaded, then you will get to know the links. So let's go to the third problem. Which of the following is a non-categorical feature? So there are 4 options. Non-categorical features means it should be continuous. Categorical means there are fixed number of categories present in that feature, fixed number of values it can take. So not categorical means it should be continuous. So there are 4 options: gender of a person, height of a person, types of mountains, nationality of a person. So these are the 4 options. Which of the following is not a categorical feature? So many of you are writing B in the chat, which is height of a person. So this is certainly continuous. Height of a person can take any value within a certain range. So height of a person is continuous, so it is not a categorical feature. And other 3 options are categorical, like gender of a person is, if you take 2 or 3 genders are there, so it has to be categorical. It is not continuous for sure. And types of mountains, which is also categorical. There are certain types of mountains, and it cannot be continuous. And nationality of a person is also categorical. I mean, so which is certainly not continuous. So only one option is correct here, which is height of a person. And many of you have written B. Many of you have written B and C, but C should not be right. type of a person, not the height of a person. I mean, a type of mountains. Type of mountains cannot be continuous. It has to have certain number of types. So this is question 4. Which of the following tasks is not a suitable machine learning task? Not a suitable machine learning task. Four options: finding the shortest path between pair of nodes in a graph, predicting if a stock price will rise or fall, predicting the price of petroleum, grouping mails as spams or non-spams. So which is not a suitable machine learning task? So the many students have already written option A in the chat, which is the correct answer here. So finding the shortest path between a pair of nodes in a graph. So the students who have studied computer science, they might know that this is a classic graph theory problem. So for which we have certain algorithms like Dijkstra and Bellman-Ford. These algorithms are present to find out the shortest path between a pair of nodes in the graph. So we don't need machine learning for that. But for other three options, B, C and D, predicting a stock price, if a stock price will rise or fall. So this prediction is certainly a kind of machine learning task. We can do it using machine learning. Predicting the price of petroleum, yeah, this is also a machine learning task. You can predict price of petroleum based on historical data and also some other features. And grouping mails as spams or non-spam, this is also a very popular machine learning task, and it is a supervised learning task because you are grouping the mails based on spams or non-spams. So these last B, C and D options are all machine learning tasks, but A is not machine learning, which is a graph theory problem. So we don't need machine learning for finding the shortest path. Some of you had written D, I don't know why, but D should not be right. Grouping mails as spams or non-spam, this is a very popular machine learning problem. But most of you have written A, so this is right. Yes. 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 KNN. I mean, you have to find out the path. How can you find out path using KNN? KNN just gives you some output value. No, I mean sort. So do you know the what is a graph as we know in math or computer science? I mean, yeah, from math or computer science point of view, graph is a different. Graph consists of nodes and edges. So it's not like in a plane you have some discrete points and that is a graph. No, you will have edges between those vertices or nodes. So that is a completely different thing. Like this. So graph consists of so can you see my drawing on the slide? So these are different nodes or points, as you can find. So these are nodes or vertices we call, and you might have such edges between some pair of nodes, and so for some pair of nodes there won't be any edges. This is what we call graph. Like this can be a graph. Okay, so it consists of nodes and edges. It is not like the distance is just the shortest distance, the Euclidean distance between them. So distances you can go via only those edges. So let's say from this point A to point B, so you can go like this, this and this. So this is the only path. This is the path. This is there is another path. You can go like this also. So this is what we call a path in graph. So it's not like the distance is just the Euclidean distance. It is not. So using KNN you cannot do that. So the graph here is different from what you are thinking of. Okay. Yes. I didn't completely understand your question. Yes. Yes. Hmm. I mean that is not a graph. So this stars is just set of some points in the sky. So here in computer science or mathematics background, what we call a graph is that it consists of some nodes or vertices, and some pair of nodes might have edges. Those represent some kind of relation between those vertices. It can be reachability relation, or can be like friendship relation. So every point is not a friend of all other points. It can be friend with some points, it cannot be friend with some others. So edges represent those relations between different a pair of points. So if you for your stars example, that it is not a graph, it is just scattered points. I mean that will depend upon what kind of graph you are considering and the application of it. If it needs. No, Google Map is working on this graph theory basis. It uses normal graph theory algorithms. Like it generally uses Dijkstra. It the other three options. Yeah, the three options. I mean, yes, BC are certainly supervised learning. D can be supervised or unsupervised based on whether you have the level, output level or not, whether spam or non-spam this level is present, then you can present it as a supervised learning problem. It might happen that you don't have those levels, then it can be modeled as a unsupervised learning problem, and you have to use clustering based algorithms for grouping spam non-spam. Okay. Yes, so this is the fifth problem. What is the use of validation dataset in machine learning? I hope all of you have gone through what is training dataset, test dataset, and validation dataset. Then you'll be able to answer this. So, what is the use of validation dataset in machine learning? There are four options: to train the machine learning model, to evaluate the performance of the machine learning model, to tune the hyperparameters of the machine learning model. None of the above. Many of you have written B in the chat. Which is to evaluate the performance of the machine learning model. So most of all of you have written B in the chat. Some one person wrote C, others have written B. The B option is to evaluate the performance of the machine learning model. But for evaluating the machine learning performance of machine learning model, we use test dataset, not the validation dataset. Validation dataset has a different purpose. Validation dataset also has the class levels and everything, just like similar to training data, but we set the validation dataset aside from the training data for to tune the hyperparameters of the machine learning model. C would be the right answer here. B is for B is the use for test dataset, not the validation dataset. So C would be the right answer, which is to tune the hyperparameters of the machine learning model. So why we need validation dataset is that you create a machine learning model, and using your training data, then you use the validation dataset to tune the different hyperparameters of the model. Like hyperparameters can be for a neural network, it could be what is the depth of the neural network and how many neurons you would need. That is a hyperparameter, not exactly a parameter of the model. Parameters are the coefficients. Just like the coefficients of linear regression. So to tune these hyperparameters, we use validation dataset. How much we can tune these hyperparameters to get better results, to train it in a better way. So C would be the right answer, to tune the hyperparameters of the machine learning model. That is the main use of validation dataset. And many of you wrote B, but to evaluate the performance of the machine learning model, that is the use of test dataset. We use the test dataset to find out the generalization error or the actual the performance of the machine learning model. Is there any doubt in this? Because many of you wrote B. If you have any doubt, you can tell me now. So validation dataset is very much like training dataset, but you don't use it for training. So you set aside the validation dataset, and test dataset, like you have never seen that data. But validation dataset, you will see that data for tuning the hyperparameters. So you train using the training data, then you have this validation dataset, and you check the accuracy on the validation dataset. You see that there is some scope of improvement by tuning this hyperparameter. So you tune that one, and then again train using the training data. Then again find the accuracy using the validation data, again tune some other hyperparameter. So you have this validation dataset to tune the hyperparameters, but test dataset can never be used for tuning or training or anything. It is just for testing how good our model is performing. Yes. And so it is divided from the training dataset. And validation data is set aside from the training data. You train only on the training data. No, I mean there are three kinds of data set you use for. I mean validation is treated. I mean yeah, you use while training, but you just after training using the training data you find out the accuracy using the. Yeah. Yes. Yeah, it is unseen during the training, but you don't train on validation dataset. It is not unseen for you. You don't use it. I mean, you have gone through linear regression, isn't it? I mean, whatever. I mean, if you have gone through machine learning model, so any kind of machine learning model, you what is the use of training? Like you use that training data, you feed the training data in the model, you find out some error value. Based on that, you update the parameters of the machine learning. That is how neural network or any kind of machine learning model works. So that is the training process, that you uh, compute the error. Based on the error, you tweak the parameters on the of the model. That way you train the model. That is the training part. But validation dataset is not used for training the machine learning model. For any machine learning model it is. I mean I'm just giving an example. For any algorithm, validation dataset is not used for training. It is used to tune the hyperparameters only. You don't train on this, on that dataset. No, hyperparameters, you while training the hyperparameters are fixed, all fixed. Like in case of neural network, you see the what are hyperparameters. Yeah, I mean linear regression. Yeah, even in case of let's say regression, so you just consider a normal linear regression with some features, but so in that case it is of degree 0. So then you might consider polynomial regression. So you that can be on kind of hyperparameters. I'm saying hyperparameter can be for different algorithm, it can be different. Even in case of linear regression, you use the regularization. So the regularization coefficient can be a hyperparameter for the algorithm. You while training you fix that. You don't change it while training. While training you change only the coefficients or the parameters. Hyperparameters are different from parameters. It is fixed while training. Then again you using validation, you see how much how good is it performing. Based on that you can change that hyperparameter. Is my screen visible? Okay, so let's go to the sixth problem. Which of the following is false about PCA? I hope all of you have gone through PCA. It is part of week 2 module, principal component analysis. So these are the four options. PCA is a supervised learning method. It identifies the direction that the data has largest variance, maximum number of principal components less than equals number of features. All principal components are orthogonal to each other. These are the four options. So the correct answer for this question would be A. PCA is not a supervised learning problem. It is an unsupervised learning problem. You don't use the Y values or the output level for training the PCA. And other options B, C, D all are true, because the B is the actual objective of PCA, where that you try to find out the directions along which the data have highest variance. This is the actual objective in PCA. And C is maximum number of principal components less than equals number of features. This can also be verified from the actual algorithm, that number of principal components or the number of extracted features that you get from PCA cannot exceed number of features, number of the original features. And all principal components are orthogonal to each other. This is true. All principal components are orthogonal to each other. This is how the algorithm is built. So only the option A is right here, that A is PCA is supervised method. This is false. It is an unsupervised method. So it's almost 1 hour since the start of this meeting, so I have to create a new meeting link and share, otherwise this meeting will end in next 4-5 minutes. I am creating a new meeting link and sharing it in the chat, and you have to join the new meeting link for the next 1 hour. I've shared the meeting link. I've shared it twice so that it remains visible. So first click on that link and then leave this meeting, and I will also join the meeting in 2-3 minutes after all of you have gone there. Don't leave this meeting without copying that link or clicking that link, otherwise the chat would not be present there anymore after this meeting ends. So follow that link now. I am waiting for 2-3 minutes. I will also join the new meeting. Still there are 50 students almost. Please join the new meeting link that I have shared in the chat, and the next 1 hour we will have this live session on that new meeting. I will join in 2-3 minutes after all of you have joined the new meeting. Then I will end this meeting and join the new one. Some of you might have joined just now, 2-3 more persons. So for them I am announcing once more that 1 hour have already been done in this meeting, and Google Meet doesn't allow for meetings to go for more than 1 hour. So I have already created a new meeting link and I have shared it in the meeting chat. Please follow that link and join that meeting. We have to end this meeting in few minutes. I'm ending this meeting now here, and I'm joining the new meeting. Yeah, I've sent the meeting link again. Now I'm ending this meeting, and after the meeting is ended you will not be able to get this chat back. So those who have not clicked this new link, please do it as soon as possible. Is my screen visible? So we can start this second hour. Okay. Okay, so this is the sixth problem. So sixth problem is done. So let's move on to the seventh problem. So this is based on KNN regression. So you are given a data set, and you have to apply KNN regression with k equals 3, and you have to use Euclidean distance to find the closest 3 points in this case. 4 options are given there. So what is the prediction for a new input 3,2? So the new test input is 3,2, for which you have to find out the output y. So I hope all of you have understood KNN regression from the video lectures. So this is a easy question. Just you have to find out the distance from each of these training points to the new data point 3,2. Find out the distance values for each of the training points to the test point 3,2, and then you have to take the 3 closest points, and you have to take the average of these 3. So this is the answer. So the easiest possible way is to, all these points are integer valued points, so it's very easy to plot them on the xy coordinates, and from this plotting you can find out which are the 3 closest points. So either you can find out the Euclidean distance using the Euclidean distance equation, or you can just plot these 6 points and find out the closest 3 points from the new point 3,2. The red point is the new point, and all these green points are the test points. So you have to find out the average of the 3 closest points, average y value of the 3 closest points. So these are the 3 closest points, training points, and you will just find out the average of these y values of these 3 points, which is the 3 closest points are 2,2, 3,3 and 4,1, and the average over y is the y values of these 3 points, 2,2, 3,3, 4,4, 4,1. So you can find out for 2,2 it is y value is 2, and for 3,3 is y value is 3, and for 4,1 y value is 2.5. So you have to take the average of these 3 points, these 3 y values, 2 plus 3 plus 2.5 divided by 3, which is 2.5. So this is the data set, and the new data point is 3,2, for which you have to make the prediction. So you can find out the Euclidean distances by using the Euclidean distance formula, or you can plot these points, because all these points are integer valued points, so it's easy to plot them in a xy coordinate plane. And after plotting those points, you can easily observe which are the 3 closest points, because k equals 3 here for this KNN regression. So you have to find out the 3 closest points, which are these 3,3, 2,3, 2,2 and 4,1. These are the 3 closest points of 3,2, and you have to for the y value of the new data point 3,2, this is the new data point, so you have to just find out the average of these 3 closest points. So 3 plus 2 plus 2.5 divided by 3, the answer would be 2.5. Is there any doubt in this question? If you have any doubt about the process or method, you can ask me, else we can move on to the next slide. So the next question is, which of the following is an unsupervised learning problem? Multiple answers may be correct. 4 options are given: predict a student's performance in the final exams, predict rainfall for a given day, group flowers based on similar features, and predict whether an image contains a dog or a cat. You have to find out which of these following is an unsupervised learning problem. Multiple answers may be correct, only one option might also be correct. So the correct answer is C in this case. So any kind of grouping based on similarities comes under unsupervised learning problem, because you are grouping the objects only based on similarities, not based on some output level that you have for that for the training data. So that's why any kind of grouping or clustering is an unsupervised learning problem. So option C is the right answer. All other options like A, B and D, so each of these are is my screen visible now? I lost connection for a few seconds. Am I audible and is the screen visible? Okay. So C is the correct answer in this case. A, B and D are supervised learning problems, because predicting a student's performance in the final exam, so you are predicting the student performance, that has to be based on some output levels, so this is a supervised learning problem. Similarly, predicting rainfall for a given day, this is also kind of a regression problem, so which is a supervised learning problem. And D, which is predict whether an image contains a dog or a cat, so this is a classification problem which has to be supervised learning problem. So only C is the correct answer here. So let's move on to the 9th problem. Which of the following is a reinforcement learning problem? Multiple options may be correct. 4 options: learning to drive a cycle, learning to predict stock prices, learning to play chess, learning to predict spam levels for emails. So which of these following are certainly reinforcement learning problems? Which of these 4? So I hope most of you already know what is a reinforcement learning task. So in reinforcement learning, it is different from supervised and unsupervised learning problem. So an agent interacts with the environment to learn some kind of task based on the reward signal that it gets from the environment. So the environment reinforces the agent to do some specific task. So in this case, A and C are the correct answers. Many of you have written the correct answers in the chat. A and C are the correct answers because learning to drive a cycle. So this you are an agent and you try to learn the cycle in the environment based on the reward signals that you get. That is whether you are able to balance your cycle, whether you are falling off or not. So based on that reward signal you learn. So that is a reinforcement learning task. And C, which is learning to play chess, this is also a similar thing, that you play the chess, and based on that, you whether you win or not, based on that you change your strategy in a temporal fashion. Based on that, so you make your strategy based on that. So that is also a reinforcement learning task, that the agent interacts with the environment and based on that it gets some reward signal and it chooses its strategy. So the C is also a reinforcement learning task, but B and D are not reinforcement learning tasks. Someone has raised his hand. Keval Krishna, do you have any doubt in this?
Yes, sir.
Yes.
Sir, why not D is the part of this?
Predicting stock prices is a supervised learning problem. Yes. That is part of the reinforcement learning. It's super that data also becomes part of the supervised learning problem, that you are moving some mail from inbox to the spam, and computer gathers the data and sends it to the server, and that becomes a labeled data there. So it gets used in the training itself. So that becomes, I mean, the A and C are certainly reinforcement learning problems, that you interact. Yes. B, I mean, learning the predicting the stock prices is generally supervised learning problem, because you have the labeled training data, historical stock prices data, and based on that you try to. I mean, there are specific things that you are talking about, but in general, A and C are certainly reinforcement learning problems, and B and D are generally supervised learning. I mean, you can form any kind of, there are certain, then right now if you read the state of the art research, you will find semi supervised learning problems which are between supervised and unsupervised. So if you try to reason that way, then any kind of problem can be represented as reinforcement learning problem, but that is not the case here. Generally, A and C, which is driving a cycle, learning to play chess, learning anything kind of any such process that you try to learn, is a reinforcement learning task. But predicting stock prices is generally supervised learning problem. I mean, you can form it as a reinforcement learning problem and train reinforcement learning agents for that, but this is not generally a reinforcement learning problem. Similarly, for spam, the spam filtering, the spam filters are based on either supervised learning problem, supervised learning algorithms, or it can also be unsupervised learning, spam or fraud detection. All these are either supervised or unsupervised, but generally not reinforcement learning. So A and C are the correct answers here. So the 10th question, this is a question on probability. A bag contains 2 red, 3 green, 2 blue balls. 2 balls are drawn at random. So what is the probability that none of the balls drawn is green? So both the balls that you draw are not green. So what is the probability of that? Two students have already written in the chat D, which is 4 by 7, but that is not the right answer here. Please check your calculations again. Both the balls are not green. You have to find out the probability of that. Some of you have written B also. It's getting unshared all the time. I have to share it again. So how can you solve this problem? What is the probability that none of the balls drawn is green? So two balls are drawn. So green balls are not drawn. So how many non-green balls are there? So two reds and two blue balls. So there are 4 non-green balls from which you have to draw. So you are drawing 2 balls. So it's 4C2 is the number of ways you can draw non-green balls, isn't it? 4C2 is the number of ways you can draw non-green balls. And what is the total number of ways of drawing any 2 balls, which is there are 7 balls, 2 plus 3 plus 2, so it's 7 balls and you are drawing 2 balls from it. So it's 7C2 is the sample size. So it's 4C2 by 7C2. So it is 6 by 21, which is 2 by 7. So 2 by 7 should be the right answer. Some of you have changed their answers to C. So is there any doubt? You can ask. Two by 7 is the right answer. So you first find out how many ways you can draw 2 non-green balls. So there are 4 non-green balls. So 4C2 is the number of ways. And what is the sample size? That is how many ways you can draw 2 balls of any colors. So that is 7C2. There are 7 balls in total. So 4C2 by 7C2. So it would be 2 by 7. So 2 by 7 C is the answer. So let's go to the 11th question. The linear regression model y equals a0 plus a1x a2x up to a p xp is to be fitted to a set of n training data points having p attributes each. Let x be n cross p plus 1 vectors of input values augmented by ones. That's why you have p plus 1 columns here because of the augmented column of ones. And y be n cross 1 vector of target values, and theta be p cross p plus 1 cross 1 vector of parameter values such as a0, a1, a2 up to ap. If the sum squared error is minimized for obtaining the optimal regression model, which of the following equation holds? So you are simply doing what you have done for linear regression. So you have to minimize the sum squared error, and if you apply that, then which of these four options hold? It directly comes from the calculations that you have already seen in the linear regression lectures. I have got one answer in the chat. Sai Mathura Krishnan has written D. Any other answers? This problem looks big, but it's just simple linear regression, as you have already seen in the class. The same model is used, same terminologies are used here, and you can easily derive the correct answer from the formula that you have got in the class. So if you have followed the linear regression, so the optimal theta is x transpose x inverse x transpose y. This is the optimal theta for the linear regression after minimizing the sum squared error or the residual sum of squares, whatever you call the error function. So from there you can just multiply x transpose x to both the sides, so you get this. So which is this option D. So from the optimal theta you just have to multiply both the sides with x transpose x, and you get the option D as the correct answer. Many of you have already written D, so D is the right answer. You just have to remember the optimal expression, optimal closed form expression for theta after minimizing the error function. So D is the correct answer. So this is the calculations. I mean, you can also see the calculation in the from the class notes, similar to that. Question 12. Consider the following statements: assertion and reason. Two statements are considered here. Orthogonalization is applied to the dimensions in linear regression. This is the assertion, and reason is orthogonalization makes univariate regression possible in each orthogonal dimension separately to produce the coefficients. So which of these two are correct, and whether R is the correct explanation of A or not? This is what you have to answer. Whether both A and R are true or not, that is the assertion and reason are true or not, and whether R is the correct explanation for A or not. A is orthogonalization is applied to the dimensions in linear regression, and R states that orthogonalization makes univariate regression possible in each orthogonal direction separately to produce the coefficients. Sai Krishna has written A. There is both A and R are true, and R is the correct explanation of A. Is there any other answers? Yeah, so all of you have written A so far, and A is the correct answer. So both A and R, that is assertion and reason, are true. Orthogonalization is applied to the dimensions in linear regression that we have seen in the class, and the main reason behind is that so that for every dimension we can separately use the univariate regression model so orthogonalization makes this possible, that we can use univariate regression method on every orthogonal direction. Otherwise, if a dimension is dependent on some other dimensions, then orthogonality is not valid, so we might not be able to apply the univariate regression. We will not be able to apply actually in univariate regression. So by orthogonalization we are able to do this. So A is the right answer, that both A and R are true, and R is the correct explanation. Is there any doubt in this? Let's go to the 13th problem. Suppose that we have n independent variables x1, x2 to xn, and dependent variable is y. You are applying linear regression by fitting the best fit line using the least square error on this data, a simple linear regression you are doing, and you found that the correlation coefficient for one of its variables, let's say x1, with y is minus 0.005. So this is the correlation coefficient between x1 and y, minus 0.005, which is very small. So which of these three options are correct? That regressing y on x1 does not explain away y, regressing y on x1 explains away y, given data is not sufficient to determine. So you have to find out whether x1 is important for the predicting y or not. So the first option is regressing y on x1 does not explain away y. That means x1 is not very important for predicting y. And option B says that regressing y on x1 explains away y. That means x1 is very important for predicting y. And C is given data is not sufficient. So regressing y on x1 does not explain away y. That means x1 is not very important for predicting y. So this is the right answer, because correlation coefficient of x1 is minus 0.005. So correlation coefficient is from minus 1 to 1. This is the range for any correlation coefficient. And if the absolute value of the correlation coefficient is close to 0, that means it is not, the correlation is very small, very little. So in that case y is not very dependent on x1, y is not very correlated to x1, because the value is very small, minus 0.005, almost close to 0. That means x1 is not very correlated to y. That means it is not very important for predicting y. So A is the right answer. Regressing y on x1 does not explain away y. You would need some other features as well, because x1 is not able to predict the value of y very correctly because of the very small correlation coefficient. So you would need other variables. That's why A is the correct answer. This is the 14th question. This is the final question for this session. Bias and variance are given by 4 options are given. So which of these expressions represent bias and variance? Keval Krishna Singh has written A, Sai Mathura Krishna has written D. Any other answers? uh, so the bias term is the bias term doesn't contain the squared. So please check your class notes. So bias doesn't have the square. So many of you have written D, but bias should not have the square. So bias generally represents the basic error that you are doing, that is the expected error from your hypothesis, from your model, and what is the the error between the expected prediction of your model and the actual output. So the expected value of f cap x minus fx, that is the bias, is simply this. This is just the the error in your output, and so the not its square, only this term, and so either A or B should be correct because bias should not contain the square terms. And what is variance? Variance is just the variance of your prediction model. Of your prediction model is f hat. So the variance of f hat is what? Expectation of f hat minus f hat, and square of this expectation of this, which is option A. This is nothing but variance of f hat x. So variance is just variance of f hat x, which is the variance of your prediction model, and if you expand it you will get this big expression, this one, expectation of square of expectation of f at x minus f at x. Yes.
Sorry to interruption in between.
Yeah.
Sir, variance is expectation of f of x minus f of x whole square will be there. I was also thinking of fx square, but as I have seen the notes, right, it is written that whole square.
Yeah, this is whole square here. Variance you are talking about, right? Variance you are talking about. Yes, square is there. Yeah. So variance of f at x, you just have to remember this variance of f at x, and if you expand the variance, so bias is what first let's consider bias. Bias is expectation of f at x minus fx. So if fx is f of x, this is the correct output. It is not your prediction, this is the correct output, and f hat x is your output. So yeah, so expectation of f at x is the average prediction that you are doing. You do it several number of times and then you average it out so that you get a certain number, because for different runs you might get different outputs from the model. So this is why the expectation of f hat x minus fx, this is the error that you are making in your prediction, isn't it? This is your prediction and this is the correct output. This is the bias. And variance is the variance in your prediction that you are doing. You are doing f hat x, so variance of f hat x, and if you expand the variance term, variance is what? Variance of z is expectation of z minus expectation of z whole square. This is the variance. So variance of f hat x you have to consider. If you expand it in terms of expectation, you would get this big term, expectation of square of expectation of f at x minus f at x. So variance is variance of your prediction, the prediction you are doing. You are doing f at x, so variance of that, how much variability is there in your prediction. It should be lower, on the lower side, that for the same input you should not have very different output from your model. Similarly, bias should also be reduced because error should be very low. So these are the two terms. So if you expand the MAC loss, you will get bias square plus variance plus some noise part is there, which cannot be reduced. Okay, so A is the correct option. So these are the problems that I planned to discuss for week 1 and week 2. And now if you have any other doubts and questions, feel free to ask.
Sir, could you go to that graph?
Okay, first I will explain the graph one. I mean, those who don't know what is a graph from the mathematics or computer science point of view, so graph consists of several vertices. I will not be able to comprehensively discuss it because it is out of scope for this course. So there, yeah, so the this is the graph that I drew. So graph contains. Oh, okay, that one. Oh, okay, okay. A KNN question you're talking about, right? This one? Oh, okay. Oh, this one. I thought that graph one. Okay. So here, so in KNN regression, what we do is that we have to find out the k nearest points of the test point that we are given. We are given 3, 2, which is the new input point for which we have to make the prediction. So we have to find out the k nearest points. K equals 3 in this case. So 3 nearest points we have to find out for the point 3, 2. Okay. So this is the training data set that we are given. X1, Y, X1, X2 and Y. These values are given. This is the training data set we are given. So for this problem specifically, if you all the points are integer valued, so it's easy to plot them on the graph. So you can see this graph. So these green points are all the training points that are present in this table, X1, X2 and Y. Y is the value, output value. So X1 and X2 are the two coordinates here. So you plot these points like 2, 2, 3, 3, this is 4, 1, this is 6, 3, this is 5, 5, 5. So you plot all these training points.
So you plotted
Yes, so X1 and X2, Y, I'm not considering Y in this plot. So this is X1 and X2 are the two coordinates here. These are the two features that you have for the data. Y is the output value for which I am not plotting anything. So X1 and Y2, according to X1 and X2 values, you plot this 2D data, and then you have to then you will also plot this test point which was 3, 2. So this red dot is your test point, and from this plot you can easily check which are the 3 nearest points. So these are the 3, this one, this one and this one. These are the 3 nearest points. And so in KNN regression you consider the next the nearest k points and find out the average of all their y values. So y value for this point and this point you consider and take the average. Is it all right?
yes, sir.
Okay. Yes.
Sir, in a linear regression, we have y comma f of x.
Yes.
So when we are doing the square,
Hmm.
sir, obviously it's called square, then it is y minus f of x comma square.
Yes.
With the expected prediction.
Hmm.
And the expectation of y minus f of x square.
Yes.
Sir, when we are integrating y minus f of x comma square to power rating of dx comma dy, what is it, sir? Can you please explain?
I'm not sure which part you are talking about. In the video lecture I have to check that what I mean, is it present in the video lecture?
Sir, I will tell you part number 1, which has been established for y minus f of x comma square.
Hmm.
Okay. So when we are using the when we are elaborating this problem
Hmm.
with dx
Uh, I have to check the video. You can post it in the discussion forum. I have to check that specific part in the video lecture. Otherwise, I am also not clear what I did or what you are talking. So I have to check it, and then I can answer in the discussion forum. So it's better if you write it in the discussion forum.
Sir, in this
Yes. Yes, yes. So here specifically k is 3, and if k is 4, then you have to find out 4 closest points, and then average, take the average of all the y values for the all 4 points. Yes. Okay. Any other questions or doubts? Yes, yeah. So for univariate regression, so okay, let me go to the last slide. So if you are regressing y on x1, let's say, so what is the coefficient that you get? If it is beta 1, then it is x1 comma y. This is the inner product of x1 and y, and inner product of x1 and x1 and x1. So inner product is like dot product. So I mean x1 is a n dimensional vector. There are n data points or training points you have, so it's n cross 1. Y is also same. Y is also like n cross 1, and you take the dot product, that is the inner product, and then you take the dot product of x1 on x1, and this is the coefficient that you get by regressing y on x1. So beta 1 is the coefficient corresponding to y x1. Similarly, you will find out coefficients for other features as well, x2, x3, that way. Any other doubt in this? Yes. Yeah, z is the residual that you form after every regression, and then you regress on z. No, you regress z on xi, xj, like that. Residual error, that after every regression you get the residual error, and next time for the next regression you don't regress on y, you regress on z. I mean you regress z on other x, the x values. Okay. Does anyone have any other questions or doubts? Those who have doubts, they can stay in this meeting, and those who do not have doubts can leave. No, I mean no. No, for the final exam, I don't know for this course what will be that will be decided by the instructor and the regular TM. I don't know, the instructor and the NPTEL team would decide that. The live session TS don't have any idea about that. Okay.
Sir, will the instructor will take the doubt classes?
No, mostly these live session TAs would take these doubt clearing classes. If instructor takes any class, the NPTEL would inform you. But every week, the live session TAs would take the sessions. 4 TAs are there, so 4 sessions every week.
Does the second my TAs can mail to us?
No, we will not mail. NPTEL would handle all that, all those link sharing things. Uh, but I will upload it in YouTube, and then I have to submit the link to NPTEL, and then after that they might share these links with you. Any other questions or doubts?
Excuse me, sir. Should
Yes.
we be part of any forum on is there an open forum?
Yeah, there is a discussion forum for this. A Google group is there where different students post different questions and doubts. That is present there in the course web page only. There is a ask to question, ask to answer, something like that is written in the course web page. Ankura Revarkar has written some question. Can you please give some more examples of supervised and unsupervised learning? So, supervised learning problem is that you have the output levels or some kind of target variable in the data that you want to predict. So, any kind of problem can be a supervised learning from that sense, that if it has these output levels predicting something, predicting whether an image contains a person or not, whether the the predicting the temperature for next few days, something like that. So when you are predicting some specific output variable, then you must have that in your training data also, otherwise you will not be able to predict that. So if your training data is labeled like that, it is a supervised learning problem, and if the label is not present, then it is an unsupervised learning problem. So in unsupervised learning, you are just grouping the objects based on similarity features. You don't have the explicit labels to predict or classify. Those who don't have any other doubts may leave this meeting, and those who have any doubts, you can stay and ask. Thank you everyone. You may leave this meeting. Thank you everyone. You may leave this meeting. I'm going to end this meeting now. Thank you everyone for joining this meeting. I'm ending this meeting now.